hydrocarbons. So we start from there. Remember we've talked about what hydrocarbons are. So hydrocarbons are basically organic compound that contain only carbon and hydrogen. Carbon and hydrogen. That's what we call hydrocarbon. If you look at the atomized point, I say contains only carbon, which is C, and hydrogen. They form the basic carbon skeleton. So they form the basic, when we talk about forming the basic carbon skeleton, we're talking about most of the organic compound we have, they emanate from these hydrocarbons before we now have other additives or substituent, we call them substituent element or compound that bond with them to form other families of organic compound. So their functional group basically is just, we have the C. They are known for having just single bond and they are saturated. The carbon to the hydrogen bond is single bond, you see it there. And the carbon to carbon also, they have a single bond. Or for the alkanes. And for the alkenes, they have their carbon to carbon, they have a double bond. And we have the triple bond for the alkenes. Then we have what we call the cycloalkanes. We'll see that later as we are going down the notes. We'll see the structures. We have what we call the cycloalkane and then bicycloalkanes. And we have the polycycloalkanes. Cyclo in the sense that there is a ring structure formed by the carbons. A ring structure formed by the carbon bonds, either single or double bond. There is a particular family of hydrocarbon that is noted for this ring structure, and that is benzene. Benzene is actually known for the ring structure. So, so we have the aromatic rings, that is the arenes. So benzene is an example of that arenes. So we are going to look all these properties about hydrocarbons. In all this we just made mention of, just a summary of what the property. Let's start with the alkanes family. Sorry for the typing you see, but I believe you get to know it, how we write chemistry form. It's not the first time we are seeing it. Well, the first one is good. CH4. We have maintain CH4. We have ethane CH3. Propane, butane, alkane. But the fact remains that they all have a general formula, and that general formula you need to know and memorize. The general formula is CnH2n plus 2. So that is the formula noted for the homologous series. You see, you watch my arrow. Are you seeing the arrow?
Yes, sir.
Good. See what you mean by the homologous series, forming a particular family. This is their general formula. So once issued, then we have the higher alkanes as C5, C4, C6, thereabout. The first to 1 to, let's say 1 to 4 of this family, they are gases. The ones that have, like methane now, methane have just 1 carbon, is it not? Are you saying that? Okay, ethane have 2 carbon, 1, 2 carbon. Propane have 3 carbon. So the ones the carbon is just from 1 to 4, they are gases. Then from pentane, hexane becomes liquid. So most times you see the petrol, kerosene fall under the heptane family, decane. So all this between 5, 6, 7, they are excuse me, please. Okay. So decane. So all their name come from the Greek prefix prefix means names you add before. Is it? We have all their names end with ane, A-N-E, and methane, ethane, propane, butane 4. We have pent. Pent, you know, pentagon, is it not? Hello? Yeah, pent meaning 5. Pentane. Hex means 6. Hexane. Hept means 7. Yeah? Okay. You want to ask a question? You said what? Okay, okay. Are you copying it? Hello? I'll give you time to write a note. Please, let's just do the explanation. Then I'll give you time to write. Is there a way you can download it?
No, I'm recording it. I'm recording it already.
Sorry, your line is breaking. See if you can repeat what you are saying.
I'm recording it. I'm recording it already, so yet I will download it. No, I say I'm recording it already, so yet I will download it.
Okay, okay. The screen will show like this now.
Yeah,
so you can get. Yes, so you can write it later. So please, so let's just listen to the explanation so that we get it right. So we have pentane, like pentane. I say the name pet is from meaning 5, all from the Greek prefix. From the Greek prefix, that's why we have this attachment of those things, and their names end with A-N-E. Ane. A-N-E. Ends with ane. So, okay. So let's look at the alkane isomers. Before then, I will take you back to what isomers are. What are isomers? Isomers are compounds that share the same molecular formula, but they have different molecular structure. Isomers are compounds. They have the same molecular formula, but share different molecular structure. They have different molecular structure. So alkane isomers, we're going to look at the carbon skeletons. The carbon skeletons, most times you have is the straight chain, the branch chain, and the cyclic chain. There are 3 ways you can see the carbon we arrange. The carbon can be straight chained, that's all the carbon to carbon bond, just straight. And we can have the branch chained, where you have 1 or 2 branches. And we can have what we call the cyclic chain. The cyclic chain. Okay? Atoms connected in a different order. All the atoms are connected in a different order. So the constituent of an isomers, all atoms are connected in a different order. That is the structure that is different, but the number of each of the elements they contain is the same. So let's pick an example: butane and isobutane. They will also have a 3-pentane isomer. So let's look at butane isomers. I want to look at butane isomers. Butane, we know, contains 4 carbon. You want to ask a question?
No, sir. You were breaking up, that's why.
Okay. Butane contains 4 carbons and 10 hydrogen. We have 4 carbons and 10 hydrogen. Let's look at the structure we have there. This is a straight chain. This is